Hey everyone, I'm Joseph Schimmoller, and I'll be attending the University of Notre Dame in the fall of 2026.
My name is Ryan Damasco, and I'll be attending Georgetown University in the fall.
Hi, everyone. My name is Christian Gorgy. I'll also be attending Georgetown University in the fall.
I'm Kingston Scotti, and I'm going to be attending Southern Methodist University in the fall.
For our final project, we sought an answer to the question, is there an association between coffee consumption and GPA among Loyola students by conducting a hypothesis test? Globally, coffee is the second most consumed beverage after water, with an estimated 2 billion cups enjoyed every single day. This same trend applies here at Loyola, where Cubs often purchase coffee at Z's or bring some from their local coffee shop on the way to school.
While researching, we were also reminded of an anonymous quote which says that some coffee plus some thinking equals some great ideas. In our data collection process, we asked the same two questions to each randomly selected person. How many cups of coffee do you drink on average daily? And what is your GPA?
In our population size of all 327 Loyola seniors, we assigned each student a number from the roster listed in alphabetical order. Then, using randint 1 to 327, we found 75 unique numbers. We then sent the 75 randomly selected seniors an anonymous response survey with the questions mentioned on the previous slide, where the data was later organized into a scatter plot.
And so we identified our variables, set up the hypothesis test for linear regression. Our explanatory variable, our x variable, is the number of cups of coffee consumed per day. And our response variable, the y variable, is the average weighted GPA. Because we wanted to determine whether there's a linear relationship between coffee consumption and GPA, the correct inference procedure is a linear regression t-test, or t-test for the slope of a regression line. Since both variables are quantitative and we are testing whether the slope differs from zero. Our null hypothesis is that beta equals zero, meaning that there's no linear correlation between coffee consumption and GPA. Our alternative hypothesis is that beta does not equal zero, meaning that there is a statistically significant relationship between coffee consumption and GPA. We conducted the test at a 0.05 significance level, and after calculating the regression output, we found the test statistic and p-value.
Looking at our data trends, our scatter plot reflects a positive, roughly linear, and weak association between GPA and daily coffee consumption. It can also be noticed that we have a single outlier, but we decided to proceed with caution anyways because if we were to exclude that single outlier, the line of best fit is still effective for the remaining data. As GPA increases, daily coffee consumption appears to increase, albeit very slightly. Most students choose to drink about 0 cups of coffee regardless of their GPA, so coffee consumption doesn't really seem to be a strong predictor of their GPA. And based off of our line of best fit, it's predicted that for every single coffee drink, your GPA will increase by 0.008897 points. It must be noted that due to a great lack of response bias from our initial Google form, it's possible our results are inaccurate due to non-response bias. With that in mind, we accept that our residual plot has a random scatter because there isn't an observable pattern in our data.
And so there are potential sources of error in our study, as Joseph mentioned earlier. For example, our sample size was relatively limited, which may reduce the reliability of the results. In addition, coffee consumption was self-reported, so some responses may not have been completely accurate. We also assume that all observations were independent because each participant filled out the survey on their own. In addition, there may have been confounding variables such as sleep, stress, study habits, etc., that could have affected GPA. Finally, because this was an observational study, we cannot imply causation, meaning we cannot conclude that coffee consumption directly causes changes in GPA. Now, for type 1 errors and the hypothetical errors, a type 1 error could be concluding that there's a relationship between coffee consumption and GPA when there actually isn't. And a type 2 error could be when we're failing to detect a relationship between coffee consumption and GPA when one actually exists. Now, a potential consequence of the type 1 error is a significant increase in coffee consumption. This could potentially be harmful because too many milligrams of caffeine can be dangerous or even lethal when taken in mass consumption. A potential consequence of a type 2 error is a decrease in coffee consumption. In the short term, this can mean that some students who work better with coffee in their system stop taking it, and as a result, see a decrease in their overall academic performance.
As you can see from our summary table, our test statistic T equals 1.152 with 16 degrees of freedom. This gives us a final p-value of approximately 0.2662. Since our p-value of 0.2662 is greater than our chosen significance level of 0.05, we fail to reject the null hypothesis. This means we do not have convincing evidence to conclude that there is an association between daily coffee consumption and the weighted GPA of Loyola's class of 2026. Any trend observed in our sample data can likely be attributed to random sampling variability.
Thank you for listening. And on our concluded slide is our works cited page linked with the anonymous Google form sent out and the applet/data collected from our hypothesis test.